Welcome to the iLearn Virtual Campus. Please sign up for a free iLearn membership on our website, check out our 7th annual conference coming next spring 2021, and let us know if you're interested in hosting events or leasing space on our campus by emailing campus@immersivelrn.org.
Hi, Lucas. You're there?
Yeah, I'm here. You want me to?
Okay, we have everything set up. I don't know which of you are going to talk today.
It will be Rafael, but I can do this.
Okay, Rafael. Okay, I'm going to in the session and then I pass to you, Rafael.
Okay.
Hello, everyone. We are back to our next session in ASMR 2020. I want to introduce my colleague, Rafael Roberto. He's the poster co-chair, and he will deliver this session to you. Enjoy.
Hello, everyone. We will continue with our poster and demo speech session. Yesterday, we had half of the posters being presented in the expo hall, and we had some demos as well. Today, we will continue with that, and we will show the speeches of the other posters, as well as some of the demos that will be presented today. So enjoy, and yeah, please play the video.
Hello everyone. I'm very glad here to introduce our paper entitled Understanding Physical Common Sense in Symmetrical Reality. Symmetrical reality is a unified concept that assumes the virtual world and the physical world exist symmetrically. The forward control and the reverse control construct the bidirectional mechanical control paradigm, which affects the physical common sense of symmetrical reality systems. Hello everyone. Today we would like to introduce our paper entitled Machine Intelligence Matters, Missing Human-Robot Collaboration Based on Symmetrical Reality. Our purpose is to show a new paradigm of human-robot collaboration in the context of symmetrical reality. We briefly show the task definition in symmetrical reality and the human-robot interaction with equal status. And we also introduce the applications of human-robot collaboration in symmetrical reality.
We propose an augmented reality and virtual reality hybrid system based on Kinect camera for lower limb balance rehabilitation of post-stroke patients. An AR-based sense is used to quantitatively evaluate balance ability of lower limbs. And the evaluation results can be used to customize training in training sense. Data such as coordinate of gravity center and angles of joints will be displayed after evaluating and training.
RDW techniques allow users to freely explore an immense virtual world within a limited space on foot by subtly manipulating the position and orientation of the virtual scene. We proposed an RDW controller that is more flexible and efficient in spatial usage than the conventional heuristic RDW controller by using reinforcement learning. The results show that our method can reduce 25.6% collisions in simulation and 19.6% in the user study compared with the heuristic method.
We introduce a new sense of quality for AR-assisted process guidance. Combining guidance with an external inertial sensor and machine learning extends sensing capabilities to task detection and even quality estimation. We first evaluate the SLAM and marker tracking using a precise reference system, and second, our machine learning-based task detection and quality estimation in a manual labor use case. The tracking accuracy of under 5 mm and a mean F1 value of 93.8% speak for our enhanced system.
In 3D object tracking, we observed that the color and edge features are complementary for different cases, and thus propose to fuse them for improving tracking robustness. We propose to fuse different entry terms with respect to a set of local bundles. Each bundle represents a local region containing a set of pixel coefficients for computing color and edge energies, in which two entry terms are adaptively weighted to play advantages of them.
My name is Florian Schuster from the Mixed Augmented Virtual Experience Laboratory at the University of Applied Science in Schweinfurt. And how this little toy truck helped us to explain 74% of the variance in the acceptance of augmented reality in an Industry 4.0-like working environment. That is what we want to show you in our poster contribution.
While directional guidance is essential for spatial navigation, little has been studied about providing non-visual cues in 3D space for people with visual impairments. To understand the effects of different non-visual feedback for 3D directional guidance, we conducted a user study with 12 blindfolded participants who were asked to point 10 virtual targets under 6 different feedback designs. Our findings show that the value of the beeping sound and stereo sound feedback.
We propose reductive AR, a novel AR framework that applies the same context as an AR scene in the environments with different layouts. To express scene context, we construct a 3D scene graph for real environments based on its 3D semantic map generated from RGBD images. By comparing the 3D scene graph with a preset AR context, our framework achieves context-aware content arrangement in an online manner.
In this poster, we are presenting a novel concept for unconstrained natural walking in a virtual environment. We want to utilize 6 degrees of freedom industrial robots for natural walking. We present the requirements originating from gait analysis and also emphasis on the major challenges in the implementation of this simulator. In this poster, we present the concepts for user interface designs of 2 augmented reality maintenance worker support systems. We start by highlighting issues in modern-day maintenance and how AR might provide solutions for them. We showcase how we designed the AR applications and the methods we used for it. Finally, we give an assessment of the AR applications by maintenance technicians. In this poster, we are presenting a pack optimization system using AR technology. The packer gets visualized the correct place of an article inside a box, and our system also detects if the article is actually placed correctly. We are using depth cameras and particle filters for achieving that. Finally, we are presenting the results of an assessment of our system. AR maintenance instructions should at best be created by the technicians themselves, as they know best what information they need for performing the maintenance task. However, placing 3D objects in reference to the real machine is often unfamiliar for them, and therefore we present here our 3D content editor that can be used by technicians and also reduces the machine access time.
Good day, I am Peter Fashogman from Nokia Technologies. I'll be presenting our poster paper about easy and convenient 3D model capture. Volumetric capture of a person is an expensive and complex procedure, so we propose a system that allows easy capture and fast generation. Our main contributions are in the shape and texture improvement, as well as a scalable serverless architecture. You are welcome to join us at the poster area. Thank you for your time. Bye.
Virtual reality is candidate to become the next generation interface for architectural design review as a solution to the growing complexity of the projects and the relative CAD models. We put together a multidisciplinary team and implemented a novel test methodology, scenarios and tools to compare VR with 2D interaction with a coherent test platform using Rhinoceros as industry standard CAD software. We did not find differences in cognitive workload, but the user preference was clearly towards VR. Come and visit our poster.
I have no idea what I'm doing. Common thoughts that run through your head when wiring up a box. Fortunately, AR technologies can make the process a little bit easier. However, usability issues can still result. For example, in our system, we found the AR-only condition was significantly more usable than the AR and text version. Learn more about our exciting research by reading our poster. What role does usability play in instructional design? Well, actually, quite a bit. We compared 3 modalities, and we found that in certain cases, non-AR modalities can be better when instruction is involved. Although different user interfaces were used, there weren't necessarily usability differences. To learn more about this exciting and innovative research, we encourage you to read our poster.
Games in VR have been gaining traction lately, but simulator sickness is still a problem. Thus, we intended to investigate a method to detect it in real time based on in-game character movement and users' physiological data. So, we designed an experiment with 3 kinds of games, collected the information in them, and trained a long short-term neural network. Our results indicate that in VR games, our model is accurate and efficient to detect simulator sickness in real time.
There are a few works using 3 or more interaction modalities. We propose a gesture-speech AR system, namely GGSAR, and we investigated 5 representative modalities and evaluated the system in a table lab scenario. The experimental results show that the gaze and gesture and speech is superior in terms of performance.
As passionate sailors, we believe that augmented reality can assist navigation, safety, and make it more accessible. The complexity of the activity and the environment make this research novel and challenging. We performed a literature review, analyzed the visual assets, and developed novel concepts. The outcomes of this ongoing research can be valuable in other fields and applications. Come and visit our poster.
This ongoing research presents augmented optical illusions approach. The representation of optical illusions includes ambiguity, distortion, or motion perception, and finally, errors in color perception that can be seen through an augmented reality system. 3R pieces created with an augmented reality tool are considered to compare optical illusions perception through the interaction of virtual objects with real environment.
AR6 is an augmented reality-based software to support young students with learning to understand electricity. The bicycle training model visualizes the energy flow without consuming any electrons. The water pipes model visualizes the current with different water speed. The pump creates pressure to simulate potential. In the waterfall model, the source pumps water to a different height and visualizes current, potential, and power.
We present a centralized solution for multi-user AR-based interactions demonstrated through instant messaging in augmented reality. It relies on an ecosystem comprising mobile devices and a central server. The server embeds automatic processing modules for 3D scene modeling and phone relocalization. Our solution opens up great perspectives, especially in gaming or learning, where users expect private interactions between players or between training and instructor.
This paper describes a three-part interactive museum exhibition where various components are utilized to deliver a compelling mixed reality experience for the museum's visitors. In VR, the user is transported back in time. In the holographic experience, the animal is instead brought into our own world. Finally, using an augmented mirror, users can pose for an individual or group photograph with the animals roaming around them. In this paper, we discuss all of the technologies that have gone into the creation of each one of these experiences. In this ongoing work, we present a novel neurofeedback medium using AR to treat ADHD in the form of a gamified telekinetic experience. Users can inflate a virtual balloon or bend a virtual spoon by reaching the desired psychological state measured via EEG. The protocol implemented is the individual theta-beta-1 ratio training over the CZ electrode. We hypothesize that AR neurofeedback will result in a better efficacy than the graphical interfaces used today.
In this work, we deal with the problem of state detection in the field of AR assistant assembly. As you can see from the images, the visual difference between different states can be subtle. To address this challenging problem, we proposed an attention module named two-level group attention. We integrated the TGA module into a state-of-the-art object detector and tested with two proposed datasets. The experimental results show that the TGA outperforms the baseline attention module.
Extending the display smartphone with AR HMGs could open up new UI solutions, but knowledge regarding how to effectively configure the devices is very limited. Therefore, we conducted a preliminary study investigating how different properties of augmented content affect the user's search performance. Through an experiment with 24 participants, we compared 4 different augmented content placements and 2 augmented content sizes in an image comparison task. Based on the findings of the study, we proposed some recommendations for the future design of the extended display.
Hi everybody, and welcome to our poster of using AR for rules. In this work, we have focused on the COVID-19 and social distancing and how it could be achieved using a body-worn system using augmentation. In the system, we have proposed a LiDAR, a smartphone camera, and a HoloLens for visualizing. The LiDAR is used for distance estimation, the camera is used for detecting pedestrians, while the HoloLens is used to alert the user of social distances. The block diagram shows how the different components interact in their environment. These are a few of our initial results, and we do look forward to show you more in the future. Thank you for your time.
One of the key technology for AR is embedding fiduciary markers in a projected image. We propose N-dash, a hidden marker system for vector laser projection. We conceive markers flipping 2 M-sequence dashes. This system is easy for image processing and robust to perspective transformation. We get the preliminary performance in the displayed setup.
Augmented reality allows using various visual assets to convey technical instructions. However, there are no guidelines for technical writers. Thus, we asked preferences to more than 100 potential technical writers. We identified 6 information types, and, for each of them, users provided a rating of 8 kinds of visual assets. Then, we asked preference on visual assets, considering also 3 different display technologies. Come and visit our poster to discover the results of the survey.
Some mixed and augmented reality applications require an accurate and efficient representation of human shape and pose, which is usually retrieved using complex and expensive hardware. Our proposal is to provide an alternative just using an RGB camera and a deep learning architecture. LCR SMPL comes from the combination of a 3D joint reconstruction method and a parametric mesh model. This new architecture is trained end-to-end to output bounding boxes and 3D mesh reconstructions of people appearing in single images in a standalone manner.
Hi, my name is Daniel, and together with my colleagues Christian and Wolf Julian, I'm happy to present you our ISMA poster paper, A Virtual Morris Water Maze to Study Neurodegenerative Disorders. And in this work, we specifically focused on Parkinson's disease, and the project is an adaptation of the Morris Water Maze invented by Richard Morris in 1989. And we provide VR and desktop compatibility. And since there is no instrument available really for research, we make this available open source, and it includes the possibility for additional measures.
We present a prototype implementation of a 6-track sensor platform where the sensing is decoupled from the localization task. This allows for various sensor modalities to be tracked, such as vision or acoustic sensors. Based on the Magic Leap 1, the user is guided during data acquisition with sensor coverage and past sensor locations. Using structure for motion and a high-resolution camera mounted on the sensor platform, the tracking accuracy is evaluated based on the discrepancy between the logged and derived sensor locations.
Our work focuses on the creation of a generic model linking actions resulting from an activity diagram and mixed and tangible user interactions in a mixed environment. This allows the instantiation of the interaction necessary to carry out a domain-specific action without specific development. For this, we proposed and used a typology of interactors as well as a tool allowing to follow the execution of an activity diagram in a mixed environment. If you would like to know more, feel free to discuss with me around my work.
We present LSFB, a low-cost and scalable framework to collect ground truth poses in a large-scale environment. To address the cost and scalability limitation of existing ground truth solutions, we collect a dataset of both mobile phone and AR glasses moving in large-scale environments, and will release the dataset as a new localization benchmark for AR.
We present stand-shield marker, designing partly transparent markers or stacking augmented reality objects. This is the markers we designed and the demo app Totem Pole. We use center 3x3 area to detect the order, and the rest 5x5 ring area is used to rotation detection. In usage, we first detect the color of each block and match them to predefined mark colors, and use the color data to detect the order and rotation. This is our demo video. That's all, thank you.
Okay, that were the posters that will be exhibited today, and now we will see the demos that will be in exhibition today. I want to remember you that also these are the demos that you will see today in the expo hall. I want to remember you that the you can vote for the best demo in Wova. Yesterday we had great discussion at the expo hall. It was really great. So I invite all of you to go to the expo hall now and see the posters that you saw here, the demos that you saw here, and also there are some laboratories that are in exhibition over there as well. So I invite all of you to go there. Just click to the go to menu and then expo hall, and I see you all there. Thank you.
Okay, let's go to the expo hall. See you all there. Bye-bye.
Welcome to the iLearn Virtual Campus. Please sign up for a free iLearn membership on our website. Check out our 7th annual conference coming next spring 2021. And let us know if you're interested in hosting events or leasing space on our campus by emailing campus@immersivelrn.org.